So now it will start sliding. This particular thing, it starts sliding. Then somewhere when it arrives here, not exactly curved one. No. Somewhere when it arrives at this particular position, now it is going to leave the circular path. Why it will leave circular path is what we need a basic idea. Okay, let's see that what actually happens. So as it leaves circular path, so first we'll get into the basic things, what all we know it. So the mg will act here. This will be theta, this will be theta. Now when it arrives here, it will have velocity. Any reason for that? Because it has descended some height. So there is a decrease in gravitational potential G. The normal reaction will act away from the center. No, this was the basic condition. Now, okay, we'll dissolve this mg cos theta, mg sin theta. What is the height it will descend? That will check it. So this distance will be r cos theta. Radius of this, let it be r. I'll indicate here also. This r. It has descended certain height h. Now it was released from rest at highest point, and it starts sliding. As it is a curved surface, starts sliding. So somewhere at this point we'll write the equation for the circular motion. Before that, can we calculate this v? Decrease in potential G, mv square. Let me proceed here. mv square by 2. Decrease in potential G, mgh should be equal to increase in kinetic energy of the block. How much potential energy got decrease? H. What is H equal to? R minus R cos theta. So what is V equal to? 2G R 1 minus cos theta. Okay, this is the speed of the block when it arrives here. Let's write the equations of motion, dynamics of circular motion. Over providing required centripetal force, mg cos theta minus n, because the curvature, center of curvature will lie somewhere here. So this will be mg cos theta what is the expression for V? We'll substitute here. Mg cos theta minus n mv square. V square will be, or mv square will substitute. Mv square will be 2 mg 1 minus cos theta. So this will become n equal to mg cos theta. One more step will simplify. Mg cos theta minus n 2 mgr cos theta. N is equal to 3 mgr cos theta minus 2 mgr. Or this mgr, let me take outside. Okay, we have this expression for normal contact as a function of theta will get. Sir, what is
Sir,
this
I will
theta?
cancel.
Yes, sir. Divided
Yes,
by R.
sir.
R will not be there, no? Okay, this I have to take it out. Okay, by R I'll write it here. Okay, this is the expression for mg. The normal contact, will it increase or decrease? That is what. First of all, what is theta? This is theta equals 0 degree line. You can see from arrow here. This vertical line is theta equal to 0 degrees. This vertical line is what? Theta equal to 0 degrees here. Okay, now like a theta is going to increase. Theta is going to increase here. Now theta will increase or decrease, that's what we have to check it. Now at one specific angle theta, if cos theta equal to, if I write 2 by 3, the normal contact will become 0. Means for cos theta less than 2 by 3, normal contact will be non-zero. For cos theta greater than 2 by 3, cos theta, so like if one specific value will come. N can be positive or negative. What do you mean by losing contact? If n less than or equal to 0, it will lose contact. N greater than 0 means it is in contact here. Now check from the mathematics here, and one specific angle called as a theta, at which the normal contact will become 0. Normal contact will become 0 means it's going to lose contact. So I'll put condition n equals 0. This will happen when 3 cos theta equal to or cos theta equal to 2 by 3. So that angle is cos inverse of 2 by 3, at which it will leave the circular path. The block leaves circular path. Okay, fine. This is one basic condition is what he has put. Why it will leave means the normal contact will keep on. Here how much it is? N equal to mg. Then it keeps on decreases. Somewhere it becomes 0. Once it becomes 0, n0 means it's not in contact. No, because of this velocity, it is going to, and weight, it is going to move in a parabolic path after this. Afterwards, it's going to move in a parabolic path and it will come and strike the ground at certain distance. We'll go take like this. It's going to move in a parabolic path. Why parabolic path? Why parabolic path? So I need some space. Okay, then we'll put a solid one. So it will leave, we have started from A, at B it will leave, and at somewhere at C it will come and strike the ground. So the path is 2 arrows, I'm showing it. Okay, this is what the parabolic path, and finally it will come and strike the ground at certain distance. Okay, we can calculate that also. Now it will have velocity v. Can we calculate that velocity v? Yes. Cos theta equal to, substitute that, we'll get the velocity. Can we calculate the distance OC, where it will come and strike the ground here? The block finally, it will come and strike the ground with a speed vc. And can we calculate the distance at which it will be there? Why parabolic path? It's quite simple, no? Because of horizontal velocity and weight, it has to move in a parabolic path. I substitute the value of mv square here. 2 mgr 1 minus cos theta. This r is due to this. Okay. This mv square is how much? 2 mgr 1 minus cos theta, no? So this 2r will cancel out. What height it will descend? r cos theta, and component of velocity also will resolve. So I'll just only the same diagram. Let me only, instead of block, let me draw a dot. It will be very easy to show all the diagrams. Okay, this will be here. It will have velocity v. This will be g. Then it's going to move in a parabolic path. So how is the path? Path till here it was circular path. Afterwards it will be a parabolic path. What are the velocity? It will have velocity v. Don't repeat, please. Huh? Okay, what is the height? It will this height will be r cos theta. Shall we calculate the time taken to move from B to C? So for that, the equations will be r cos theta is equal to v sin theta, time taken to move from B to C, plus g tbc square by 2. Equations of motion, projectile motion. V sin theta will be along y-axis, initial velocity. Do we know v? That I am going to substitute from here. Cos theta, do we know cos theta is 2 by 3? From that I'll get the velocity here, this one. Then, after getting this, so it is going to have a displacement of x. How to calculate that x? X should be equal to v cos theta into tbc. Then what is this distance? This should be r sin theta. So what is the distance OC? OC should be equal to r sin theta plus x. Substituting and solving all, we'll get the required answer. Okay, like this, the block after leaving this is going to leave a circular path, and is going to describe a parabolic path. Will strike the ground, not here, somewhere here. Where do you can say this? I think if you go for parks, the slopes are very important. Means the what all the sliding things, no, they are very important. They are just based on these things. So if you look at the some slides, in the children's park, okay, this is called like a slide, no, it will be there like this, and the kid here will slide down. So how the curvature, by chance, if the same slide, if it is like this, this is the slide. I think, oh, everyone, this is a slide. If you construct by chance like this, okay, the kid will climb up here, then by the time when it comes here, what is the problem? I think I'll make it one dimensional. After sliding some distance, here the kid will definitely fall, no? Will become parabolic path, he will fly. At any cost, what happens, the slide, if it is straight, okay, no problem. if it's something, if you make curvature, okay, fine, good. But if you make curvature like this, definitely the kid, what happen, if it just falls from rest, it will fall here. Suppose if he starts with certain velocity, definitely the kid after coming here will not land here. He will just fly, and with his face, or he will come and bang himself with the ground here. I think the equipments what you design in park, they need all these basics here. This is the reason why we want you to learn and think. Huh? It's very sad that you go and visit some parks. No, nowadays there are some playing things are there where the curvature of like this they have made it. What is the major problem? They're going for design. Means here slide will not be there. Some sort of tortoise. Okay, on the tortoise they should slide. Okay, fine, good. Okay, tortoise shape will be like this. Okay, here is what they made that slide. So what is the problem with this? So I think the kid who is there here, he will start from here. He will not reach ground. Somewhere he will fall like this. I visited some parks. It's very sad that people without knowledge, they're designing the slides. So here the kid will climb up. Steps will be there on tortoise. Okay, kid don't know no tortoise means they'll feel happy. The kid, almost all kids I've seen, they're falling. Wrong design, lack of basic science, no science is involved. Well, where is the problem? Yes, the students without class 11, class 12, they learn so many things, they just memorize, somehow they got BTech degree, they become engineer, and they'll get a government job, afterwards gone. Somehow they'll secure government job, and they'll, if they such engineer without knowledge, if he goes and park designs, no, all such stupid things will happen. So these are some basic condition. So here what happened, the block is released from rest. It just what happened, so it starts sliding somewhere. When it makes an angle theta equal to cos inverse of 2 by 3, it is going to leave the circular path. After leaving circular path, going to describe parabolic path. Then can we calculate the distance OC? Yes, applying the projectile motion equations we can work out here. With what speed strikes also we can apply conservation of mechanism from M to from B to C, because what height it will descend, mgr cos theta. If you want, I'll go for one more. Mgr cos theta should be equal plus mv square by 2 should be equal to mvc square. So the block will come and strike this point with a speed vc. At what distance? There is a projectile motion. And now here we have released it from rest here. If you give velocity, anything will happen. If you give velocity, definitely it is going to leave circular path before reaching point B only, from somewhere here. If it slides from rest, okay. If you give velocity somewhere here, then it's going to fall. The block leaves circular path at point B and then describes parabolic motion, parabolic path, and then write it down. After this 9:30 to 10:30 we'll have a paper discussion. Don't bother, okay?
Yes, sir.
Okay, we'll take the now after this the block at is point